Well, as the buoy says, welcome and welcome to my garage. We're in Lake Forest, California, and in view now is my GTM. This is a composite body 2,100 pound modern version of a GT40. It has a Cadillac LQ9 engine punched out to about 500 horsepower, Porsche Carrera transaxle, and I've got a camera system. You can see the suction amounts that actually allows me to do 360 virtual reality videos with the car. The car was built it about approximately 3 years ago, and I use it quite a bit then, just for local driving, picking up groceries, and certainly not taking long trips. But today is a scientific experiment. What I've done is I've removed my intake air system. You can see it's a dual system, and the intake air system is designed to take advantage of these NACA decks. So, you know, these decks are highly efficient. So as the car approaches reasonable speed, the air comes down here, comes through a tube, it's filtered, and then of course it is split to the right and left side, and then fed into the mass air sensor and then into the engine itself. Now what I'm going to do is I'm going to actually do some comparison tests. And my comparison tests are really looking at the effectiveness of a product that, well, for years has been sold on eBay. And the concept behind it is, lo and behold, all you have to do is to buy one of these inline small ducted fans, and you can increase your horsepower by at least X%. But wait, if you order now, you get two for the price of one. But for the first 5,000 people that call in, you also get a set of Gunset knives. And of course, this has a double your lifetime guarantee. Well, it's like blowing through a straw in your engine, in my opinion. But there is some merit to forced air. There wouldn't be turbochargers, superchargers in the car. But the question is, how do we do it efficiently? So to try to answer that question scientifically, and more importantly to see if it works, I've designed a rather large system. This is a 90 millimeter or approximately 4-inch turbine. I'm going to power this thing by a 4-cell lithium battery pack. It has got a 200 amp speed controller. It will turn about 30,000 RPM and put out a phenomenal amount of air. Now this can consider this the ultimate leaf blower or blow dryer if you want to. You can push it up to about 40,000 RPM. Now scientifically, if you think about this 6-liter engine is 0.2 cubic foot. So that means at 3,000 RPM, we're taking 0.2 times 3,000, or approximately 600 cubic feet of air. So how much will my jet, powered by this separate lithium pack, under control of variable speed, what performance will it give me, if any? Now, as I found out on eBay, most of the performance numbers were kind of pulled out of a hat, but I'm going to try to do it a little bit more scientifically. So what I'm going to use inside is my Android tablet, and I've got a program from Palmer Engineering that feeds off my Orb 2. Now I've got it in a demo mode, but I want to point out what this will actually give you. So this particular face on it will give me RPM, speed. It will also give me boost and vacuum, which is very important for my test. And in a fully operational mode, rather than the demo mode shown here, it will give me acceleration, power, and instantaneous torque. Now I use this as a heads-up display, but for testing, it's got more features connected with it. So if I select one of these dials, just for example, let me take position number 2, and this actually gives me instantaneous fuel economy. Not that I care about it in a car like this. This is not a Volkswagen Rabbit, so you do burn a little bit of fuel. But we can also go down in here and look at engine performance. Now here are some of the gauges connected with it. So what we have here is, we'll show our timing, We show our intake and coolant temperatures. We show, very importantly for my test, my mass airflow sensor and the MAP pressures. Now the program is actually quite unique because we can go back and we can go under gauges and we can look at the gauge mode on this. So I can custom these gauges to give me coolant temperature, MAP pressure, timing, oxygen sensor reading, engine horsepower. I can also look at just various types of instantaneous fuel economies, exhaust temperatures, etc. Everything that the Orb 2 Bluetooth output will give you can be shown or recorded on this particular heads-up display. But what I'll be using then is recording information, again, not in the demo mode, but in the actual mode, to look at the effectiveness of my ducted fan 90mm brushless motor forced ram air input system. I'm in the cockpit of the GTM. It's a little unusual compared to most cars. I've designed this steering wheel to be completely remote control. So I have 16 channels on it. There's a quick release on it, and it transmits signals wirelessly to control the lights, the hydraulics, the automatic electronic hatch lifter, and various things like that. Standard set of gauges on the back. And for my heads-up display, this is the Android tablet with the dashboard connected with it. So I'll start the engine, it'll be a little loud, and then we'll see what kind of performance we get. So, in neutral, brake on. So I am connecting to my Orb 2. Connected. Back in my dashboard, my RPM is approximately 1,000. My boost vacuum is minus 7.3 psi. Of course, we have no acceleration, power and torque minimal because we're basically idling. So at this, I can go in and I can look at some of my performance monitors. This is my timing, my coolant temperature, I just started it up, my intake air temperature, it's relatively cool today, my MAP sensor, and fuel pressure. So when I rev the engine, you can see the change in the MAP pressure. So at idle, we're about there. Now I'll kick it up to about 2,000 RPM. 3,000. And then back down to idle. So you can see the recovery on the MAP sensor. I'll come back here. This will give you an idea again of the boosted vacuum. Now we're running about 1,500 RPM, and that boost looks like about 9.9 approximately. Slow it down a little bit. So we're down at 1,000 RPM, and our boost is minus 8 psi. So again, this will give you an idea of the monitoring system, and we'll be able to compare performance when I start the ducted fan. So let's start her up. Well, just to ensure that my air boost turbine system is actually working before I put it in my vehicle, what I'm going to do is actually turn it on, and you can get an idea of the sound as well as the air velocity coming out. So I'm controlling this thing. You see the flags in the background. I think it has a little bit of airflow coming out of it. Okay, so let's install it. Again, we're going to set it back here as a temporary setup structure and hook it into the intake and the mass airflow sensor. Well, I set up my temporary test configuration. So I put a couple of clamps on the side here just to prevent any vibration. But remember, the thing is going to want to start moving backward if anything. I've got a plate down here as a heat shield for my exhaust. I'm using some aluminum 4-inch flex tubing to feed the high pressure air down into the mass airflow sensor and then of course into the engine. So again, it's a static test on this. Okay, very interesting. So I guess we should see what happens. Well, since I'm working alone on this, I'll have to start the engine and come back here and then increase the potentiometer here to change the speed. And then of course I'll be here in the back and then I could film the gauge. So the problem is I need actually a second person, a helping hand then with the throttle. So again, this is just a preliminary test today to see what the difference is going to be. Well, I started it up. It is idling. Still running rough because it's cold. Let's give you an idea of the sound. About 960, approximately 1,000, and my boost is -8. So let's a little bit, see what happens. About 50, but it doesn't look like my boost has changed quite a bit.